Hey guys, so we are building into a topic that I really like. We're making inferences about a function from its derivative in this lesson. Again, we've done a little bit of this before. Here we're really developing these ideas fully. So some of you may remember I studied economics in college, and economics is like the study of how we allocate resources. And like there's a lot of business applications to it. One of the major applications of calculus in like a business sense is the idea of like maximizing or minimizing something. So for example, if I'm running a business, maximizing profit is one of my main goals, right? So finding maximums and minimums, which you guys are already familiar with, is something we're building towards in these next couple of lessons. Okay, so it's important to note as we look at these problems, these are all f prime. So I'm giving you the graph of the derivative. And in this case, we want to know the intervals on which f is increasing. Okay? So f is the original function. We don't have f, we just have its derivative. Okay? F increasing means that f prime is bigger than 0. Right? So f increasing means a positive slope, essentially. Okay? So don't get like twisted between f and f prime here. We don't care if f prime is increasing or decreasing. We just care if it's positive or negative. So notice we have a curve that's positive until we get to this point. Then it's negative everywhere else, right? So we care about, like, I should make this note too, f prime greater than 0 means above the x-axis. Okay, so that's what we're looking for here. And then we want an interval. So I think it gives you the option of using inequalities, but I'd prefer you to use interval notation, which is -9 to 0. And we're going to use a closed interval, so we're going to use parentheses actually for both. Because if we graph this function, we would find that there's a maximum at this point. It's not increasing at that point. We'll see what that looks like a little bit later. Okay, so that's the solution here, -9 to 0, because that represents this part of the curve where the function is positive, where f prime is positive, so the function is increasing. Okay, we're going to do a couple more examples so we can continue to kind of develop this thinking. This takes a little bit of practice. It's not super hard, but you might make mistakes, and that's okay. Our next one, f prime, we want intervals on which f is decreasing. So f decreasing implies that f prime is negative. F prime is less than 0. Okay, so I'll highlight those spots first. That's this spot and this spot, right? So negative, again, means below the x-axis. So those intervals are -7 to -3 and not negative, regular 1 to 8. Okay. So we see where the derivative is equal to 0 are already becoming important. Now, here's a good point to stop and pause. Think about whether you understood these last two examples. I went quick, so make sure you didn't tune out. The next ones get a little bit more challenging, so make sure you understand these before you move on. Feel free to pause or rewind. So here, determine the values of x at which the function has a local maximum on the interval -9. Again, we're given the graph of f prime. So let's think about what that means. So my graph of f, I don't know what it looks like, but I know I'm looking for points that look like that, right? So if this is f, I want a maximum. Well, let's see. Thinking about my derivative should be what do I want to say? My derivative should be positive to the left of this point and negative to the right, right? Okay. So at my maximum, f prime changes signs. And it changes signs from positive to negative. Okay, so that's what I'm looking for here. And we can think of like 0 is where a function has to change signs. Okay, so the first thing I'm going to do is I'm going to note all of my points where my derivative is equal to 0. So here's 1, here's 1, and here's 1. And let's take a look at the signs now. Okay, so I'm going to go from right to left. So positive, negative, negative, positive. Okay, so my first 0 over here, as I go from left to right, I go from negative to positive. So that's the opposite of what we want. So this is actually, that's a minimum. Then here, I actually don't change signs at all. Okay, so what like f would look like at that point is a point of horizontal tangency, but not a maximum or minimum. Okay, so that's just nothing. And then here is what I want, right? So here is my max, because the derivative is positive to its left. So my x at which f has a local maximum would be that point where x is equal to, or f prime is equal to 0 there, equals -3. Okay. We're going to do one more. Very similar problem. Here, we want local extrema. So at point at which f has a local extrema. So that just means either a minimum or a maximum. So maximum, we just saw the derivative changes from positive, so increasing, to negative. And then at a minimum, the derivative changes from negative to positive, right? Because that would look like this would be a minimum, this would be a maximum, and then maximum we're increasing and then decreasing, minimum we are decreasing and then increasing. Okay, so we're going to look at all the values where the derivative is equal to 0, so I'm going to mark those out first. So we have 3 of them, and we only care about the ones where the derivative changes signs, right? So that first one again is nothing. Okay, and actually I don't have to think too hard. So if I want to think hard about it, I go from negative to positive, so this one's a minimum at x equals -2. And then here I go from positive to negative. So that's a maximum at x equals 8. So those are our 2 extrema. I don't have to think that in depth because all it asks me is to make a list. So I just have to give those 2 spots. I don't care which ones I'm maxing them in. This is a really important lesson to move on, so don't play guess and check. So if you get stuck, make sure you come back and rewatch the video. I'm going to put at the end here a little cheat sheet for you guys to reference. Make sure you get that down in your notes.